All right, so we're looking at conditional probability today. This is just a subgroup under just the bigger idea of probability. Um, this is just probability on some sort of condition. That's why they call it conditional probability. So some notation you guys will see is this notation. We've seen the P, but then we have not seen the slash. So what the slash is going to tell us is this is the probability of A given, or on the conditions, given that B has occurred. Okay, so this is the probability. Sorry, probability of A given that B has occurred. So, okay, so that's this idea. Event A is, we want to know what the probability of event A, but we already know something has already happened. So what it's really going to do is it's going to take our sample space and it's going to make it smaller because we can get rid of some things that because we already know an event has occurred. So, all right. So if you can remember that idea, again, remember it's always like our probability is always our desired outcome, or what we're interested in. I think we've used interest, and then over the total possible outcomes. And this is going to be like after the given part. Okay. So if I look at a standard deck of cards, again, if you're not familiar with that, you can probably just Google standard deck of cards. It'll show you. There are 52 cards in that standard deck of cards. Again, it might be helpful to know what's in a deck of cards if you're not sure. Again, if you just go right into Google and just go standard deck of cards, it'll give you, you can go to the images and it'll show you. So if you guys take a look at this, again, well, this might actually be nicer. So you guys can see there's the 52 cards here. There's 4 aces, 4 twos, 3s, all 4 of each of these. These are suits, or sorry, these are the actual cards, and then the suits are right here. There are 4 suits: clubs, diamonds, hearts, spades. There are 13 of each of those that make up 42 total. So if I look at that, and let's say I define event A as being an ace, event B as being a black card. Again, if this helps you guys, there are 4 aces. There are 26 black, because there's, if you look at that set again, my clubs and my spades are both black cards. C is a club. Again, that's one of the suits, so there's 13 of those. And then D is a 10, which there are four of those as well. So I can answer the following questions. I can just simply ask, what's the probability of getting A given B? So A is an ace if it's a black card. So I already know it's a black card, so I'm only choosing from this top row here and this bottom row here. So I've got 26 total. And what's the chance that it's an ace? Well, there's 2 of them. There's this club of ace, and then there's the spade of aces. And so that would be a 2, because those are the only 2 that are interested in, and they're 26 total now, not 52, because I'm only looking at the black cards. Okay. Again, you could simplify that and write it as 1/13, or you could put it as a decimal or whatnot. Okay. Let's practice another one here. So this one's the probability of getting event D given that B has occurred. So I'm still just looking at the black cards, but I want to know what's the chance of getting a 10 as well if it's a black. Well, again, this is going to be out of 26 because there's 26 total. Well, how many black 10s are there? Again, a lot of you guys probably know that already, but there's 1 and then there's 2. So there are 2 for that as well. So this would be 2 out of 26, or again, 1 out of 13. Chance of that occurring. Okay, let's move away from the given black. Let's look at this next one. What's the chance of getting a club given that it's an ace? So again, I know I'm drawing from just the aces is what I'm looking for. If you look at that, there are 4 aces. So I'm choosing from those 4 cards. How many of those 4 cards are clubs? Well, if I'm choosing just from these 4 cards, there is 1 club for that. So this would be 1 out of 4 chance of that occurring. And that's really just conditional probability. It's just changing your outcomes really. And so you've got to take a look at what you've got. Okay. Let's look at another different example from a two-way table. So if I have a two-way table here, this is just favorite sports to watch on TV. And we're going to make one selection from this group. Again, I've got males, and then I've got football, basketball, baseball. That was the only thing that was in that survey. And so sorry for you, lacrosse and volleyball and soccer people, but that was all that was on this table. So if I look at this, I can answer conditional questions from this. We've already answered just regular questions, but we can answer conditional. So again, this slash is going to tell me it's given. So the event A is being male and event B is football. So this would be, what's the probability of selecting a male given that they like football? So I'm going to look at the total outcome first. So how many total people like football? Well, there are 52. So that is going to be my denominator. If you recall, everything else with two-way tables we did out of 60. But now we are only interested in those that like football. So of those 52 people, how many are males? And that'll give us our probabilities, which there are 40. So that would be 40 out of 52. And again, you can simplify that. It actually does not matter one way or the other. If you were, that would give you 10 over 13, or that's like I don't know, like this would give you like a 76.92% chance. So, but again, you can just leave it as a fraction if you like, or a decimal. I actually like percentages. Probably put it as a percentage for this. This would be a good idea. On your test, you're gonna have to put it as a percentage. Okay. So if I look at this next one, this is event A is now basketball, and event B is being female. So if I look at this one, what's the probability of selecting somebody that his favorite sport is basketball, given that they are female? So I'm only looking at the people that are females first. So that would be 45. That becomes my denominator because that's my total. And then I think out of those 45, whoops, not 45, I apologize. Don't make that mistake. I actually do not have the totals this way. So if you guys notice, I've got to have the totals. Some of you guys probably saw that already. So plus, I've got to plus all that line together. So that would give me 77 here. 12 plus 16. That would give me 73 here. And then, wait, I don't have to do that. So let's get 150. Sorry about that. So this actually is not 45. I need the total females, which total females will be this 73. Okay. And then out of those 73, how many liked basketball? It would be this 16 right here. And then I'm just going to go 16 divided by 73. And that will give me 21.92%. So there's that chance of selecting somebody who likes basketball, given they are female. So be careful with that on this table like we had there. And then that should really do it, guys. Again, that's conditional probability. It's been your math moment with Mummy. Adios.